Uh, so the last time we discussed the some part of the production theory and the related to the production, and the two main thing what you have to look at the producers short-run decision. We discussed the in terms of long-run decision. What will happen? The producers, like we discussed, doing two ways to reach the economic efficiency. One, try to minimize cost a given amount of production. The production amount at the end given with that. For instance, here, what we call this is the ISO cost curve, and the budget, let's say $200, $100, $80. So at this different budget, keeping producers try to produce minimum cost. Now let's say you want to produce 8 units. So that keep the target like 8 units. Now some producers can produce the 8 unit here, for instance, point A, and even same like the point B also, but the cost is 200. Most efficient producers bring down the cost further, and the produce at point somewhere here, point E, they are get the economic efficiency. They are decide to recruit number of laborers and the number of capital. So that's the way producers get, and more than $100, not enough money, even can't reach that way. So the optimal point, you reach the point E. That's way objective to keep as the minimize cost. So minimize cost subject to given amount of production. Given amount of production. So, or maybe some producers doing opposite. They target the as objective maximize output amount of output given cost, that is subject to cost. Okay. Now, if you saw the graphically something like this, the reach to maximum amount of output. Let's say the different isoquant curve reflect the output. Let's say starting with the 80 and go further, let's say 100 here, second one. And 200 here. The isoquant curve, it can maybe go further also. Now, we know the producers, rational producers produce more and more, which means go to higher isoquant curve. But they have the limited or given cost. So that reflect the isocost curve. Sorry. Here. Though now let's say $100 isocost curve, the amount of the budget $100. Though with the $100, they can produce less than 100, which means even 80, for example, here and here, whatever. The rational producers try to maximize output and can produce 100. So in the reach to this point, can't go further because no enough money, no enough budget. They are the objective set as the maximize output but subject to, which means the given the budget. So the amount of money at the end of the day given. Now you can notice that the either way, no need to do both way, a producers reach this optimal point here. I take another slide and here, whatever way, ultimately producers optimal point, they get the point here, let's say point E. Now you can see the point E produces point E, slope of the isoquant curve equal slope of the isocost curve. What is the slope of the isocost curve? Input price ratio What is the slope of the isoproduct curve? MRTS. With this way, this is the condition. The optimization at that point it decide the number of labors, number of capital. In that way, we can derive the labor demand function, the capital demand function, or input demand function. Right. Now, one example, let's say, given production function, I'll take a very simple one, LK. Now, the cost like that. Let's say you were given the exam cost is say $100. Let's say W is $4, R is $5. Now, what we have, isocost curve is given, $100. Now, to find the optimal level, we have to go for maximization. So find Q, this amount. For that, we have the constraint, then we have to write the Lagrangian equation. So that first we write the output function, that is the objective function, and add the constraint. So that's what we call Lagrangian equation. Then now we have one equation. We have one equation. So there what we have to do, this differentiate the decision variable or unknown variable. What are the decision variable? We want to know how many number of labors at this point recruit, how many number of capital also. This Lagrangian equation, the lambda also not, we don't know. So with that differentiation, we get the first order condition. First order condition. When differentiate the Lagrangian equation with respect L, so that was the first order condition. First equation, you know, when you differentiate this one, it's become K plus here. Here also L, then we get the W. Now, we get this equation and we set equal to 0 because the optimal point, if you draw a curve like that, optimal point, the slope becomes 0. So in that way, we get the first equation. And also we have to differentiate this Lagrangian equation with respect K, because the K also, we don't know, that is the decision variable. When you differentiate, we get the answer L minus R equal 0. So that way we get the second equation. And also lambda we don't know, then we have to differentiate with respect to lambda. Lambda mean here, the basically to increase additional unit of output required amount of additional budget. So we can, it's a shadow estimation. When you differentiate, what we get here, C minus WL minus RK. With that way, we get another equation we name as a third equation that is also set to 0. This is the first order condition, 3 equation. These are the first order condition, 3 equation. Why we set them equal to 0? Because in the optimum point, we want to find the first differentiation, we have to set equal to 0. So the last time, I think differentiation rules, when I teach you, I discuss those things. Now what you do, using this equation, you can find answer to L and K Even we can find lambda also. So those are the value what you get here, K and L. Now the first thing what you can do is the first equation, if you divide by second equation, you get the answer K divided by L equal W divided by R. So that's what you get here. Now look at this new thing what you got here, K divided by L. So the K here, when you differentiate the production function with respect L, the answer what you get here, marginal product of labor. When you differentiate with respect K, the answer you got here, what you call marginal product of capital. So what basically here we have marginal product of labor divided by the marginal product of capital, which means the MRTS. MRTS. So this point, that equal only happen this point because the W divided by R. W divided by R. Directly also, if I don't ask in the exam, use the Lagrangian process. Answer to this question directly, you can start from here using this condition, like what is the MRTS. So that's what we call direct method, MRTS equal input price ratio. With that, you can start and write. Now, from here, rearrange this equation number 4. Rearrange in equation number 4, we can rewrite W L equal R K. Now I name as equation number 5. Now when equation number 5 plugged into equation number 3 here, for example, WL here, what is equation number 3? T minus W. Then if you plug WL here, what you get here, equation number 3 now become C minus RK minus RK equals 0, which means 2 RK equal C. Now what we get, not T, sorry. Yeah, 2 RK equals 0. Now K equal C divided by 2R. So you can see and similarly you can get the L also, that come C divided to W Now here, the example I give, the C is 100, which means cost 100. Now look at the capital, how many units of capital we recruit. 100 divided by 2, R is 5. The answer becomes 10, which means the optimal level, 10 capital, this producer recruit 10 capital. Similarly, you can find the number of labors, which means 100 divided by 2 multiply here 4, 8. So answer what you get the about 13 the labors. So the optimal level recruit about 13 labors. So the given the cost 10 capital and 13 labors recruit. With that you can find the maximum optimal amount of output produced because you have the production function here. So there you can find the Q equal 10 multiply 13. So 130 is the output you can produce. That is the optimal amount. If the exam questions come like that, I think you can do it. Now the second part of the exam question, I may give you, let's say, this particular producer particular industry, the wage rate, other thing remain constant. I can merge also, but wage rate increased by $1. Now new wage rate is becoming that way the $5. $5. So with that, what happened is original situation. Output, we got the 130 Q1. Here budget 100 budget. Initially $4. Maximum you can recruit. The initially what we had the R is 5, the maximum recruit. So that ISO cost curve we get. Now with this new development, the wage rate has increased. What happened? This budget line, sorry, ISO cost line rotate like this and came to optimal level like that. Now with that, what happened? The producers now can't reach or can't produce 130 as original. So they can optimal level, they can produce somewhere here, the lower ISO quant curve. Exactly, we don't know right now. For that you can find because you know the labor demand, what you get previously, here we already found C divide by 2W. Which means the C is 100, the W now 5. The labor you can recruit 10 unit. Capital also, capital price did not change. Now capital also 10 unit. Now the previously you recruit 13 labors. Now with development you can recruit only 10 labors. The previously capital recruit 10. Now you can see after the wage rate is increased, now should able to produce because the production function I gave you, LK, which means the labor 10, capital 10, new production now you can produce only 100. Now suppose you run a firm, with this wage rate has increased or is due to tax or whatever, now your firm can produce weekly or daily, that's a certain 100. But initially, due to demand, you produce 130. Now, though wage rate increase, your production reduce up to 100, the market need, you have to send to the market your clients, 130 clients there. Now, my questions, next third question in that way, in the exam, I will ask you to produce initial amount of 130 output. 130 output, that is the original output. As a production manager, you have to ask from your account or whatever the department or top management additional budget. Because $100 you can't do right now, since the wage rate has increased due to tax or whatever, or revision. Now, you should be able to find the additional amount or maybe total new budget. So that you have to do. That, now you can see clearly output target is given this time. Output target is given 130. So then you see something like this. This output target here. Now we have to find if I go to original, here output target is 130. You have to reach because there is the market demand. Then what you have to do, this second ISO cost curve, you have to shift. I mean, graphically, if you show second ISO cost curve, I used as a green parallel. It touch the original. Sorry. It didn't come properly. Yeah, something like that. The original ISO quant curve at this point. Which means you have to ask to increase your budget and get new budget. So there, what you really have to do, cost minimization because the minimum cost what we need to produce 130 right now. This is the objective now. Subject to given amount of output. Now output is given 130. I'll take the original example production function. Now here, Lagrangian you have to write. First objective function WL. Sorry. WL plus RK U minus LK. So constraint we add and wrote a new equation that is called Lagrangian equation. Now we get that. Now there are single equation, then we can usual optimization. The first order condition this differentiate with respect decision variable or unknown variable. Lagrangian equation first with respect L, Lagrangian equation with respect K, other lambda. Here the lambda mean the shadow budget. Now we try to get the point here L and K. In the exam, you have to draw the graph like this in the same graph. Now include 3 budget line because my one is a little complicated here. So like that, not the separate like. But this is the now new budget required, what you have to find. When you differentiate with respect to L, we get the answer W. Here also L, then you there get the lambda K. There are also, as usual, first order conditions set equal to 0, you get the one equation. And with respect to A, also you get the R, L, 0, you get the second equation, like that. Now, with respect to lambda, which direct you can get the Q equal, sorry, Q minus LK equal 0. Like 3 unknown variable, 3 equation, then you can sort it out. Now, like previously, here also this part, when you differentiate the production function with respect L, this become the marginal product of labor. Likewise, here this become marginal product of capital. Now, when you divide the equation by second equation, you can get the direct result here. Price ratio divide or equal MRTS. MRTS means MPL divided by MPK. MPK. So you can see here the W divided by R, that is the first part here, equal, here K is the marginal product of labor, L is the marginal product of capital. You get the equation number 4. Equation number 4. So rearranging this equation, you can get the, like L equal R WK. So I still use this equation number 4. Now this equation number 4, if you take and plug into the equation number 3, you can find the L, I use this time L hat and A hat. Here, got to get the LK equal Q. That is the equation number 3, rearranging. Now for L, I take the equation number 4 and write R divide W K. The remain K also here, the K and equal Q. Now what we get here right now, K equal W R Q Q root. Similarly, you can find the L also. There you get, doing the exercise, you get the R W Q so that you get. Now we get the amount here, the L. Now, for example, now W and R 5 divided by 5. Q is 130. The square root. Yeah. I don't have a calculator, but you can find 130 is around somewhere around 11 point thing. Let's say the 11 point number of labor now need 11, let's say roughly. Similar, the capital also, number of capital you need 11 somewhere around. Right? Like here. $11 labors, 11 capital. With that, you can produce original amount 130. The new cost the budget, additional budget, and you need W new labor amount plus new capital, then you can find new cost. W is 5, 11 plus R also 5, 11. So the new budget, what you need $110. So after increased wage rate, now exactly here I can't draw, but this is the original situation. Before increase the wage rate, there you remember capital you required 10, the labor 30. So I'm drawing the one single chart because the exam you have to do. Now after that, what happened? The wage rate increased up to $5. Wage rate increased $5. Then the ISO cost curve rotate. The producers would be able to produce only second 100. There are 10 laborers, sorry, up here. 10 laborers and 10 capital, the rate code. Okay. That's how the exam question comes, and there are 4 steps. The first, get the labor and capital demand function, and then the changes adjust. And the last point, you have to draw like a chart in the single graph. And in addition, one open questions like recommendation and the managerial question related to this, I will give you. So any other, for example, here what you did to adjust the wage rate changes, in this case, wage rate increase, what the producer asks higher budget, 110. I may ask the question instead of that, what are the other strategies the producers can adopt? Producers can use, stay in the market, this producing same amount after wage rate increase. So that you might have a different ideas, different managerial thinking. And what really happened in Sri Lankan case, you can see that reduce the quality, but that is not the proper way of the product can produce same thing. And also Sri Lankan way, we can see, and our producers reduce the size of the product also. For example, bun, roast bun, those things, when compared to the size, around 2010, 2015, now become smaller and smaller. So those kind of things also, but I'm not telling these are very good strategy. So you have to think of some strategies like that. Okay. Any questions? Okay. Look like no any other questions. And now, one more thing, the producers, now you notice that either they try to minimize cost or maximize output. Now, with this exercise, we can derive minimum in the mathematically what we call minimum value function, but in the microeconomics we call minimum cost function. Minimum cost function. So what I'm going to do right now with you, how to derive the minimum cost function. And also the maximization after this one, I will do how to derive the maximum value function that after this one. Now here the first exercise, the objective function. Of course, I did just now the minimize the cost. That is the objective as a producer. We did this exercise before. That is the objective. Like we said that there's a constraint when you minimize cost. You have to produce certain amount of output, then the given output subject to the output. So I take not a standard production function, I like a example production function, like I took the previous one, LK. Usually the textbook starting take the production function is as a functional form, like here, with that and derive and so, like here. Or instead of in the exam, like giving like a real estimated output function. So with that I'll do, then easy to do your exam question. But exam, I don't give exactly this production function different. You can do the past papers and you can see. Now here with the constraint like we did before, we can't do the optimization unless we write the equation, single equation, that what we call Lagrangian equation. We did before. Without explaining, I write the Lagrangian equation here. So this becomes the Lagrangian equation. Now the same as what we did the first, before first order condition, differentiate this with expect decision variable L, K and the lambda. So when you differentiate with respect L, you know the differentiation I discussed with you, W minus here also L, then become lambda K equal to 0 because the optimal level, the first differentiation get the slope become 0. With that we get the first equation. And the second, we differentiate with respect K. There we get the R minus lambda. Here also K. Then what we get the L equals 0. That way we get the second equation. The third equation, what you get when you differentiate with respect lambda, there you get the Q minus L K equals 0, like that. Now, using this equation, I'm not going to do the again steps. You can derive, you can get the answer to L and K we did before. I just go there and take them. L you get the R, W, Q, K also we did before. Yeah, the same thing I'll get. W we did just now. R, Q, root here. Now these are the optimal value. For example, value what you get here, L and K. These are the optimal value we got. Now we plug this optimal value into the cost equation. Go to next slide. This is the cost. What we have, W L plus R K. Now if we plug this optimal value here, let's say the L hat and the K hat, we get the C star. That's what we call minimum value. In the exam I'll ask, cost function. Minimum value cost function. That's the function of what you get. W, R, and Q. We'll see how it's happened. Now here, C star, W, L hat what we got here, R divide by W, Q, plus R and K hat. We got the W divide RQ. Wow. So that's the. Now we simplify this. The answer what you get here, you can see the function of W, R, and the answer what you get here, minimum value cost function 2 W R Q power O square. That's what we call minimum value cost function. Next time I'll ask you get about 100 marks, sorry, 10 marks, but you have to do 10 marks, how you get it. First write the objective and the issue here, problem, they are 1 marks. Then the Lagrangian 1 marks. The 3 first order condition equation 3 marks, the other 5 marks and solve and get this L hat here, K, and the rest of get the 10 marks. Now, we got this minimum value cost function. When you differentiate it with this respect parameters. What are the parameters? W, R, and Q. For example, here, when you differentiate with the minimum value cost function with respect W, we get L hat, which means the R, W, Q, Similarly, when you differentiate this minimum value cost function with respect R, you get K hat, which means when you differentiate this one with R, you get the value W, R. You have to do differentiate and see the power 2. This exercise, what he did here, you get around 4 marks, or it depends on the other question, 3 or 4 marks. This exercise, what he did here, called separate lemma. Yeah, separate lemma is separate this come from mathematics. He's a mathematician. His name is called separate lemma. Now in the exam, again, given those production function, I will ask you to derive minimum value cost function, and after that perform separate lemma. So that you get about 15 marks or 14 marks or 15 marks for all the things. So that the exercise. So, but the exam, I may give a question, production function. In this case, I give a production function, this one. In this case, I give a production function. As an example, I use the LK. But the exam, you practice, you have past papers also, production function like that, Q equal, let's say L, A, Karu. Or maybe in the exam, I'll give a production function like this, A, so is the constant coefficient here, and L, alpha, K, beta. So, for third one also, maybe I give you can practice before the exam. Or maybe I give a little simple one. L alpha, K beta. The other thing same because the cost equation and everything thing. So these three, including the one I did also here, to practice several times. The exam you can get easily about 15 mark out of 20 question, other 5 marks drawing and other thing can get. Okay. I hope you understand right now. Now, the last point today, what we did here, we derive minimum value cost function. And also using the maximization, we try to get the second point here. We derive maximum value function. Maximum value function. Now, point here, as a producer, ultimately try to maximize profit. I mean, even try to maximize output. The ultimate purpose is profit maximization. So what is profit? Revenue minus cost. Now the cost equation we know, we already in W, L, in case of L and K, two variable, two input case, you can add all the input also, we can do that. Now the R is revenue. Revenue is E, that the price, multiply Q. Multiply Q. Now let's say the production function, the same one. I'll take the same production function, but exam you can practice the others also. Simple production function L and K. Now the revenue, you can see the P is given. P you can, you know, in the market already there. Then to find the revenue is not your job because the P is market available and the LK. Now the profit here, equation now we can rewrite the profit equal E, that is the market price, L, which we don't know right now, optimal level, number of labor and number of capital also we don't know. Minus now the cost is here, W, L, that is the labor budget, minus RK, that is how much you expend for capital. Now this is quite easy because you got the single equation, no constraint, because the profit is a function like here. No constraint. So you are going to find the maximum point here. So it's straightforward. No need to constrain minimization and constrain maximization. Now here, to find the slope optimal point, you have to go for first order condition. What is the first order condition? Slope must equal to 0. Then we differentiate the profit function. Now we don't know at that level profit, how many labors and how many capital. So differentiate with L. So you get answer P, K minus W equal 0. So that is the first order condition, first equation. And K also we don't know, then the differentiate with respect K. So we get the answer PL minus R equal to 0. Second equation, what we got? Now only two, the unknowns and the two equation what we got here. From these two equation, we can find L, that is the optimal amount of labor accrued at the profit maximum level, and the K, that is the optimal amount of capital you recruit at the profit maximum level. So basically that we call input demand function, labor demand function and the capital demand function. Input demand function. Answer what you get here. L star is the R P. RP. The capital input demand function become W P. Now this, the optimal value function, if we plug into profit equation here, this one, you get the optimal value profit function. Optimal value profit function. So I'm going to another slide. Now, what you are going to get the optimal value profit function. The profit is P, we know that. L now, take there what we derive, the optimal value labor input, and the K, same what we derive, minus W, we know the market, and L star, minus R, the K star. So when you plug those into, now what we found, L star RP, K star WP, ultimately maximum value profit function, when you plug those here, here, and here, the profit, the maximum value profit function, what you get here, answer you get the minus W R divided by the P to the power. When you can, sorry, not power, just to P, sorry. This is what we call the maximum value profit function. Now, this one we can differentiate with respect to parameter, for example, maximum value profit function. If you differentiate with respect W, you get the result R P. Similarly, if you differentiate the maximum value profit function with respect R, you get the minus WP. And also, you can differentiate the maximum value profit function with respect T. There you get the R W divided by P to the power 2. Now these are Now, first one, the labor input demand function. Second one, capital input demand function. Third one, your output function. Now we can see practically you can estimate the profit function because the profit, the value there, and the wage rate time series or cross-sectional wage there, interest rate also, the market price also. So after that, when you differentiate, you get the labor input demand function, capital input, output function. This exercise, so I'm going to mark here this exercise. What I mark here, which means when you differentiate the maximum value profit function with respect to parameter W, R, and Q, we name them Hotelling lemma. Hotelling is another mathematician. It's not a hotel. Hotelling is name lemma. So in the mathematics, the maximum value function when you differentiate is parameter called Hotelling lemma. So here what you get the maximum value function, maximum value profit function, then Hotelling lemma. In the exam, I will ask you to derive the maximum value profit function, given output function, and the performs Hotelling lemma. There you can get about 15 marks. So this slide I will share with you, and in the exam again you practice. Like previous case, I give output function to do this exercise. Maybe like this, or like previously I gave you L lambda K beta, or maybe different the value here, let's say L power to 0.4, K power to 0. Actually, this and so easily you can get very simple steps about 15-20 marks. So with that, I'll stop today. But I'm going to do this PowerPoint slide. That's what I did the PowerPoint. I will share with you. I will send to the WhatsApp. And so if you have any question or clarification, now you can ask me. If you can wait, I can wait a few minutes. Otherwise, you can leave the meeting only a few there. But today exercise, definitely 20 marks question you get. And again, I want to say that the microeconomics, I don't give a very simple paper. Paper must be difficult. And I will share with you today. I want to do that your marks. The one group did not submit the assignment. I already informed. I sent to WhatsApp. The others also, I will share the marks next week, most probably. There are some I found very, some students get very low marks, has to be careful. And again, the final exam next month, if you don't work, I see that no one interested. Right now, only few comes, and I better take the picture today. I'm not going to give you a easy paper. So because if you don't take seriously, the paper become harder and harder. So with that, I'll stop today. Thank you very much and see you next week.
Thank you, sir.